3.5, we are now talking about rotational symmetry. Let's read through the definition of this, and then we'll go through and talk about the examples. This should go pretty quickly. All right, so a figure is in a plane, has rotational symmetry, or what is called radical symmetry. That means it can rotate as we do this. If the figure can be mapped onto itself by rotating it 0 and 360 degrees about the center of the figure, called the center of symmetry, or a point of symmetry, then we can rotate it. So here's our example. We have like a diamond, which is a square, and we're at 0 degrees. If we were to rotate it to the next vertex, which is this one here, which they're showing, will it map itself onto itself? So if I were to sit there and put my finger on this or a pin or something, and then I would spin it, and it has to match exactly the way it looks if I were to rotate it all the way over to here, okay? So here is 45, we have a 90, we have a 180, and we have 270 degrees. So basically it's the line of symmetries that we just talked about that will, if it maps on itself, the chances are it's going to work. Now, the answer is, now the number of times it rotates, it's going to ask us the degrees that it rotates by. We take that number that we find that it rotates, or the lines of symmetry, and we divide it into 360 degrees, okay? So that's our biggest thing on that one. So let's go ahead and do this, okay? Because if let's go back and look. So if I rotate it 45 degrees, does it look exactly like that? The answer is no. If I rotate it 90 degrees to this vertex here, does these two look exactly the same? The answer is yes. So 90 degrees works. Okay, if I rotate it 180 degrees, would it look the same? The answer is yes. If I rotate it all the way around again to this corner here, taking this one and moving it all the way to here, the answer is yes, because they look exactly the same. Okay, and then of course, if you were to get back to 360 degrees, which is a first full circle, every shape looks exactly the same. All right, hope that gives you a general idea of what works here. All right, let's check this out. We're going down here and we're going to look at this star. So if we were to put a point somewhere in the middle of this whole thing, okay, and we were going to start to rotate this, the first thing we want to identify is, can this be cut in half? The answer is yes, and it can be done in several different ways. So if we were to do it, we would cut it through here. Okay, it looks like, and the key thing and hint is that it's, most times it's always going to be through some kind of a vertex. Does that make sense? So here we go. So we're going to rotate here, we'll rotate here, and then we rotate, and I'm not drawing a very good line here. So locate the center of symmetry and state the order and the magnitude of the symmetry. So we want to state, so how many times do we rotate again? We want to go again 1, 2, 3, 4, 5, and then we get back to this one here. So this one ends up being 1 again, and this one's 2 and 3, 4, 5. So it rotates. So we have 5 lines, right? Now with 5 lines, that means we're going to take 360 degrees and we're going to divide it by 5 to get us what our magnitude is going to be. So what is 360 divided by 5? The answer is 72 degrees. Okay, so we have a yes, 5 lines, and 72 degrees. Okay? All right, let's look at this one. This one's a little bit more on the unique side of things as far as the gear is concerned. Again, if we were to, this looks like a pinwheel a little bit. If we were to put a pin in the middle there, okay, and this one's a little bit interesting to watch. Okay, so if we were to do this, I'm going to tell you right now, I'm just going to show you because it's probably not easy to recognize. We're going to draw a line of symmetry through here. Now notice that I'm doing it perpendicular as best as I can to this line here, and it cuts it through that side. So again, we're going to do the same thing over here. We're going to go perpendicular, and then perpendicular again here. Now notice how that works is that we have a nice little triangle in the middle that looks exactly the same. So we have yes, 3 lines. And we could have, what we could have done too, instead of doing that, we could have sit there and say, okay, this is my starting point. Okay, I'm going to put an S here. And if I were to rotate this point to here, which would have been point 1, would it have mapped onto itself? The answer is yes. And we did the same thing here. If we were to put it here, Okay, that'd have been number 2. Remember, this is an S, not a 3. It looks like, kind of like a, we'll put a start. And then it rotates again one more time, so we have 3 times that it rotates. Okay, does that make sense on that? So the answer is 360 degrees divided by 3, which equals 120 degrees. Okay? All right, any questions about that one? A little bit unique on that scenario. Now we're going to do the same thing pretty much for this one here. It's not going to necessarily always go straight through the middle of the gear here. So we have a gear here. And can you see any lines of symmetry that would make it so that it rotates onto itself? Again, I like to sit there and say, okay, here's my starting point. Okay. How many times do I get to rotate around until it gets to this point? So we're going to pick each one. So here is 1, 2, because it's the same spot, 3, right? 4, 5, 6, 7, and then back to 8 again, which was our start. Okay, so you have to always finish where we started. So you could have done it that way and say, okay, yeah, it does map on that. Now, if we were to draw the picture of this, I'm going to do it in red for this one. We're going to sit there and go, okay, it's going to go through and look like this. So I'm going to draw a line here and here. So it's kind of interesting. So we're going to draw a line through here and here, and you get the general idea of what's happening here. We're going to go this way. Okay, then this way, and then that way. And again, look what it creates in the middle. It's like a square, and or in a diamond or whatever you want to do. I didn't do a very good job. If I had done it with a ruler, it would have probably been a little bit better. So again, we rotate it how many times? This one's a yes, and it is 8 times, or 8 lines, right? And then we have 360 degrees divided by 8, which is an answer of 45 degrees. Okay? Hope that helps you out. There are 2 different methods on doing that one. We can do the same thing. Now I want you to try the next one on your own, a little bit more simpler in this case for yourselves with a square. Pause the video and then come back and see what you got and if it matches what I have. Okay? All right, see you in a few. All right, welcome back. Hopefully you did a little pausing and did your work on your own. Anybody figure out what's going on here? The most common one that I always start with is I always go like this, where it cuts in half vertically and horizontally. Any other ones? Yes, there is. Okay, we can go diagonally here as well, because if I were to rotate it, now here's the thing, state whether the figure has rotational symmetry, if so, the order and the magnitude of symmetry. So now again, if I were to sit there and rotate it from this point to this point, would it exactly look the same? So is diagonally, does it work? It does not. So diagonally will not work on this. So I did that on purpose to make sure you guys understood that I'm doing this. So these ones diagonally will not work. Well, or I'm saying horizontally or vertically, whatever you want to call it, that makes it work. So but we can sit there and see how many lines? 1, 2, 3, and 4. So we have lines of symmetry, which we talked about in the previous part of this section. Or we can go by the number of vertices. We start here, and this is our start point. And we rotate it till it matches again. So here's number 2. Here's number 3. And number 4. Okay? So we get 4 lines. The answer is yes. Okay. I'm sorry, this should have been 1, 2, 3, and then 4. Okay. That gives us 360 degrees divided by 4 gives us the answer of 90 degrees. Okay. All right. Questions on that one? All right. Let's go on to the next page. And our last page for this is just a bunch of little different work here that we have to work with. All right, same scenario. So again, you should have practiced this one and this one. The answer should have been on this one. You could have drawn. Remember, I like to set drawing lines. I like to have a starting point and like to count. So here's our start. 1, 2, 3, 4, 5, 6, 7, and 8. So we get 8 of them. So if I were to do that, we would get, but the interesting thing is, because we can draw lines of symmetry, and I could have drawn them all the way through here, and then through each one of the vertices, and I would have had 8 lines total again, so it depends on how you feel comfortable doing that. So we have 8 lines, and the answer I forgot to say is yes, and then we're going to take 360 degrees, and we're going to divide that by 8, which gives us what? 45 degrees as our answer. Okay, how about this one? How'd you guys do on this one? Can anybody find anyone that would work on this one? The answer is there is none. The problem is that they don't have this part right here. If this part had existed, then it would have been perfectly fine. We probably would have had 4 scenarios that would work for this again. Okay, but since it's a missing side, it will not work. All right, now going down to example 3, describe reflections and rotations. Here it says state whether this figure has a line of symmetry or rotational symmetry. If so, describe the reflection or rotations that map the figure onto itself. Okay, so can you see if this one has a line of symmetry, and if it does, and if it does have a line of symmetry, can we rotate it? Okay, there is one right here. That one line we can do, because we can do this is called a what? Line of symmetry. Is there any way else I can cut it in half? Nope, there isn't. So guess what? Is there a rotational symmetry? It does have a line of symmetry, and if it only has one line of symmetry, then the answer is that it does not have rotational symmetry. Okay. All right, any questions on that one? All right, we're down to our last 2 examples here. Okay, now this one's a little bit unique and interesting because it has where we talk about plane symmetry, axis symmetry, or both or neither. Okay, now what it means by plane symmetry is if I were to cut this in half, so if I were to take it and just slice it down the middle like I'm showing here on this, would it look exactly the same if I were to lay the thing out, almost like a sandwich, so to say? The answer is yes. If that's the case and it matches both sides, then it has plane symmetry. Now, axis symmetry is if I were to take a pole, I'll use red, or a stick or whatever, and I poke a hole through it, like if you were going to make s'mores and poke through a marshmallow, and poke it through anywhere part of this, and then hold the stick on both ends, like this, and then rotate it. Would it look exactly the same as it rotates around that? Now, a marshmallow would look exactly the same all the way in because it's a cylinder, so that would be a yes scenario. But if I were to spin this thing, would it look exactly the same all the way around? Because this thing out here, it would end up being over here, so it does not look exactly the same. So the answer on the axis symmetry would be no. So this one has only plane symmetry. Okay. So let's look at this one over here. Same scenario. If I were to take this and cut it in half, right? Here's our center. If I were to cut this thing in half on both sides of the thing, and it would lay out, would it look exactly the same? And the answer is yes. So it does have plane symmetry. Now, if I were to stick a pole or a stick through this whole thing right here through the center, and I would spin it, okay? If I were to spin this thing and it'd go around, okay, would it look exactly the same no matter which way it spins? And the answer is yes. Okay, so that means we do have axis symmetry, so it has both. In this case, so it has plane and axis symmetry. Okay, that's our notes for today. Hope you got some good ideas out of this thing, and go ahead and start working on your homework. It'll be posted on your teams, and get those taken care of for us. All right, thank you, and we will talk to you later. Have a good Thanksgiving.